Querying rows in your dataset is probably one of the most important operations in data analysis. For example, to answer questions like how many male individuals are there in our dataset, or how many customers came in after 8 p.m. on a Tuesday, you're going to need to write a query against different rows in your data. In this lesson, we're going to see how to do this using the query method in Pandas. So let's get started. Here is our list of learning objectives. If you like, you can pause the video and read through these, but we'll come back to them at the end of the video. I start by opening up Visual Studio Code, and then I drag my Graph Courses Python folder into VS Code so we can use it there. And here's the dataset we're going to be using for this lesson, yaoundedata.csv. You should have downloaded this in a previous lesson, but if not, the link to download this will be below the video. I'm going to click now to create a new QMD file. This is my notebook. And I'll call it pandas query rows.qmd. And let's start by making an initial section called imports. And I'll open up a new code section with Ctrl-Shift-I. And I'm going to import pandas as PD. And I press Ctrl-Enter to run that. And let's open up a new section and call it our dataset. And here I'll read in my dataset, I'll call it Yaoundé and set that to be equal to pd.read_csv. Open parentheses, and I'll refer to my data folder, the Yaoundé data that I put in there. So if you have your file in a different path, make sure this path is correct. So I'm going to go ahead now and run this. And let's quickly look at that data frame by clicking on the interactive section here. We can click on the View Data button, and we click on Yaoundé to view that data frame in Pandas. And we can quickly remind ourselves what this dataset concerns. So the data is from a seroprevalence survey done in Yaoundé, Cameroon, to figure out how many people had COVID. And you have information like their age category, their sex, and so on and so forth. So we're going to be querying against some of these variables. But first, let's create a smaller subset of Yaoundé that we're going to actually use for most of this lesson. We'll call it Yao, and we'll set it to Yaoundé. And we're going to subset to a smaller list of variables: age, sex, weight in kilograms, neighborhood, make sure you spell this correctly, we're spelling it the American way, occupation, symptoms, is smoker, is pregnant, IgG result, and finally IgM result. And let's view that subset of data frame below. So we can press Ctrl-Enter to run all of this. Let's take a quick look at these. So we subsetted now to just 10 columns to make it easy to see the queries we're actually running. Now let's officially introduce the query function. So introduce query. So query basically lets us keep rows that satisfy a certain condition. It's fairly basic to use. So as an example, if we wanted to select all men in our dataset, we type yao.query. So this is a method on that yao data frame. And then we open up a set of quotes, and within that we type our query, sex equals, and then another set of quotes, and male. First of all, let me run this, and then we'll talk about a few things that we did there. So now we've run it, and we can see our output has 422 rows. Now let's take note of a few syntactic things. First of all, instead of a single equal to here, you use a double equal to indicate that we are testing for equality. This is a common mistake made by beginners, is they use a single equal to when they're checking if two things are equal. So watch out for that. The second thing is that because query has this weird syntax where we put the query within quotes, then we have to make sure that strings within that query, such as male here, have a different type of quote from the surrounding quotes. So in this case, we use double quotes to indicate the query, and then single quotes to mark out the male string. We could also do the opposite and say single quote outside of the query, like this. But then to demarcate this male, we would have to use double quotes, since you can't have two pairs of the same type of quotes nested in that way. Okay? And the last thing to note is that we have a space before and after the equal to. That is not mandatory, so you could remove it, and this still works. But generally, Python style guides recommend that you have some space around this operator here. Often after running a query, you want an easy way to access the number of values that fulfilled that query. A common way to do this is with the .shape attribute. Let me show you how to do that. Let me copy all of this over to a new code chunk. And I'm going to append onto this output here the .shape attribute. Notice that it's not a method because I'm not putting a pair of parentheses after it. So it's an attribute in this case. And if I run it, I can see 42210. So that first value is the number of rows, and the second value is the number of columns. To access just this first value, I can use a square bracket notation. So I put square bracket and then index of 0, because Python is 0 indexed. And now if we run this, we get the number of rows that fulfill this criterion. So let's add a comment here to explain what this is doing. Get the number of rows that fulfill the criterion. Now let's open up a new code chunk and just make a quick note that queries do not modify the data frame itself. So as an example here, if we type yao.query and we run that, that doesn't change the value of yao. So if I now print yao underneath this, yao still has 971 rows. If I want to modify the data frame, I can either do the following. I can set yao equal to yao.query, and this would overwrite yao with this new query data frame. But that's usually not recommended. Instead, you should create a new variable. So let's call this maybe yao mail. And then yao mail will just be the 422 rows. Okay, so if we run this now, you can see that yao mail has 422 rows. And so let's update this comment and say you need to create a new object / variable. Okay, now with all of that basics in the bag, here's a practice question for you. I want you to subset for pregnant respondents. So pregnant individuals have the is pregnant column set to yes. Okay? So subset just these individuals and store the result in a new data frame called yao pregnant. So pause the video and try that out. Next, let's talk about different relational operators in Python. So the equal to sign that you just saw is one example of a relational operator. We're going to look at a number of other ones. So we make a new section and we call it relational operators. And let's open up a new code chunk and type out examples of these. So I'm going to start with the equal to, which we already saw. So yao.query, and let's do sex equal to male in quotes. And as a comment, let's type equal to as a definition for that. And we'll copy this and paste it on the new row. And I'll show you the next one, which is not equal to. And for that, you just replace this first equal to sign with an exclamation point. And this now becomes not equal to. Now, if I run this code chunk, only this last line is going to show in my output here. I can see that there's 549 rows that are not male. So those are the female individuals. Okay. Now let's look at greater than and less than. So I'm going to type again yao.query. And then let's check where the age is greater than 7. So these are individuals aged above 7. There's 902 of them. And notice that in this case, we don't put a quote around the 7 because the 7 is not a string, it's a number. Now let's put a comment here, greater than. You can also have greater than or equal to. So let's copy that, paste it, and add an equal to sign after the greater than, and set this to greater than or equal to. And you can see there's 931 rows for this condition. Similarly, you can also do less than and less than or equal to. So let's copy this and show those ones. Actually, let's start with only the less than so we can see that output. Less than here, okay? And it doesn't show us the number of rows because it's actually printed all those rows. But let's check the number by doing shape and then subset 0. And we can see there's 40 individuals there. And we're getting to the end now. Let's do less than or equal to. So less than or equal to. Notice again that the less than comes before the equal to sign. So less than or equal to. And that gives us 69 rows. And the final one we're going to look at is called is in. And we use that to check that a value is an element in some other longer list of things. So as an example, let's say we wanted to check whether people live in either briqueterie or carrière. We could type the following, yao.query. And we set neighborhood. I'm just going to copy the word neighborhood there so I don't have to spell it out. So neighborhood here. And this is actually a pandas method. So we're going to type dot is in to access that method on this neighborhood object within here. So dot is in, and then open a pair of parentheses. And within that pair of parentheses, we provide an actual list of possible values. So let's check those that are in briqueterie here. I'll copy that so I don't have to type it out. And this is a string, so it should be in quotes. And we're going to use small quotes since we use big quotes to wrap the whole thing. So small quotes there, paste that, comma, And also this one, carrière, I don't know how it's pronounced. So let's run that query. We can see there's 342 rows, and we can quickly make sure that indeed we've only subsetted to those in briqueterie and carrière. Okay, those are almost all the operators you're going to use for your queries. Now it's time for some practice. So here I have 2 practice questions for you. So first from Yao, I want you to keep only respondents who are children, that's under 18. Assign that to a new data frame called Yao children. It should have 229 rows. And then using the isIn method, keep respondents who live in the neighborhoods. Assign that to this data frame, and here's the number of rows that should be in your result. Now, sometimes you have an external variable that you want to access within the query method. Let's see how to do that. I'm going to open up now a new section and call it Accessing External Variables. And I open up a new code chunk, and let's create some example external variable. I'm just going to call it min_age and set that to the value of 25. And now within a query, let's see if we can get the number of people who are above this minimum age. So I type yao.query. And then I open up a set of quotes and I set age greater than or equal to, and you may be tempted to just put min age directly in here, but the query is going to be looking for min age within this data frame, and it doesn't exist there. It exists externally, so you need to use this @ symbol here, @ to access that external variable. And now we can run this code to get that output. Now that's a pretty simple idea, but let's have you practice it. I open up a new code section and I call it practice Q. Subset for young respondents, subset for young respondents. And very quickly I realized that I forgot to give this other practice question a name here. So let's call it practice Q relational operators, just so we can stay consistent. So back to this one, I'm going to create now a variable called max age. I'll set that to the value of 30. And for the question, I want you to keep respondents who are less than or equal to this max age and assign that to a new data frame called Yao Young. And no offense to people who are over 30. I'm not saying you are not young. You are also very young and beautiful. Next, let's make a new section and call it combining conditions. So often you have multiple conditions you want your query to fulfill, and you can use the ampersand or the vertical bar symbol to combine with and or conditions. Let's see an example. I open up a new code chunk. And let's say we want a query for individuals that are either below 18 or above 65. We can write the following. Age is below 18, age less than 18. And then we're going to use this vertical bar symbol here, which stands for or. Age is greater than 65. If I run this, I can see my output of 331 rows. And let's put a comment here to explain what this is doing. This is age less than 18 or age greater than 65. Let's look at another example. Let's say we want people who are either pregnant or ex-smokers. We can write yao.query, and then we type is pregnant equal to yes, or is smoker is equal to ex-smoker. So let's quickly run that and see the output. I see there is a token error. I see I missed closing quotes here. I'll leave this in so you can see the kind of errors that we make. Okay, so now we have that output. And let's try pregnant and an ex-smoker. So pregnant and an ex-smoker. And let's see how many people there are here. Okay, so we have one person who used to be a smoker and is currently pregnant. Now, as a quick side note, let's quickly see how you can get the unique values in columns. For example, here I typed is smoker is equal to ex-smoker. And so you may be wondering, how do I know that ex-smoker is an actual value in the data set? So of course, one way to do that is to look at the variables in your data viewer. So as an example, let's go to view data here, and let's view that Yao data frame. And from here, I can see that within that is smoker column, we have non-smoker, ex-smoker, and smoker. Alternatively, you could write the following piece of code, Yao.isSmoker. Hopefully you recall that this extracts that list of values. And then we can use the method .valueCounts on this, .valueCounts. And if you run this, you'll see the 3 different values and their counts. Okay, now let's do some practice. I'm going to call this practice Q and subset for IgG positive men. So here's that practice question. I want you to subset Yao to only keep men who tested IgG positive, and then assign the result to the following Yao IgG positive men. There should be 148 rows after your query. Next, we're going to talk about negating operators. So often you want an easy way to negate a set of query conditions that you have created. So let's make a new header and call it negating conditions with the tilde operator. Hopefully you know where the tilde is on your keyboard. So let's see a very brief example. Let's say we wanted to select individuals that were students in this data frame. We could type yao.query, and then we're going to say in quotes occupation equals to, and then in another pair of quotes, student. First of all, let's run this, and we can see there's 383 rows. But we may want a way to negate this condition and get all values that are not student. So one thing we can do is we can wrap all of this here in a pair of parentheses. So wrap the condition in a pair of parentheses, and then use that tilde function outside of that. And if you run this, it gives you the opposite of the internal condition. So we've negated this, and we're getting people who are not students. So let's add a comment and say return individuals who do not fulfill the condition. And let's make a new section and say that what we did above is equivalent to, and hopefully you can guess what it's equivalent to. Instead of this, we can just say occupation not equal to student, and those two are equivalent, but sometimes you do want to use this negation operator. You can also use the negation operator to wrap several conditions. So let's see an example. I'm going to type yao.query, and I'll put in a regular condition here that selects for children, so age less than 18, or people with a weight in kilograms that is lower than 30. So you could imagine maybe we have a drug and it's quite powerful. We don't want to give it to children or to people who are lightweight. So this condition selects such children and people who are lightweight, and we can negate this in order to drop them. So we're going to wrap all of this now in a pair of parentheses, and then outside of that, we put our tilde. And it's nice to put a space before and after the tilde. I realized I didn't do that here, so let's do that. And we can run this now and make sure that works. So now here's a new practice question for you. Hopefully you're not getting tired of these. You need to make sure you get enough practice. I'm going to call it drop smokers and drop those above 50. And here's a question. We want to avoid giving a drug to older individuals and to smokers. So from Yao, I want you to drop respondents that are either above 50 or who are smokers, and use this tilde to negate the conditions. Okay, now we're getting close to the end. Let's call our next section NaN values, N-A-N values. So NaN is a special type of value that indicates missing data in Python, and it requires some special handling within the query method. So first you can see, for example, that in the isPregnant column, you have some of these NaN values. These pertain to male individuals, since in this dataset, pregnancy is not relevant for men, and it may be useful to query against these specific values. So let's see how we can do this. Okay. First, let's see something that will not work. So you may try to do the following, yao.query, and then isPregnant equal to maybe NaN. So you could try this, but it's not going to give you an output. It's going to give you an error. NaN is undefined. You could also maybe try putting it in quotes, but that's also not going to give you an output. As you can see, there's no values that are equal to NaN. And the reason is that NaN is basically not any value. So NaN technically stands for not a number, but it basically means no value. And so you can't check whether anything is equal or not equal to it because it doesn't exist. So it can't be equal or not equal to anything. So let's comment this out and say this does not work. This does not work. What do we do instead? Well, there's a special method to access that. And it's simply called isNa. So let's see how to use it. Let's do yao.query again. And then in quotes, we're going to say isPregnant dot isNa. And this is a method, so we need to put open and close parentheses. And now we can run this, and we can see our 422 men who have an NA value for that pregnancy column. You may also want to query for individuals who don't have an NA value. For that, you use the dot not NA method. So let's just copy this, put in a new code chunk, and type, instead of isNa, we just type dot not NA, and that gives us the individuals with not NA for that value. All right, now here's a practice question for you on that. Practice Q. I want you to keep missing smoking status individuals. Okay. So from the Yao dataset, keep all the respondents who had NA records for the report of their smoking status. Now let's make a new section and call it querying based on string patterns. So to demonstrate what I mean by this, let's make a new section, a new code section, and look at the values of the occupation column. So yao.occupation, and I'm going to run value counts on it so I can see the different values. And you can see in this output over here that this is a multi-answer column. So someone can be a student or an informal worker and so on, but they can be multiple of those things. So they can be both student and informal worker, in which case you have it separated by 2 hyphens. Or as you can see in this case, you can be a homemaker and an informal worker and a farmer as well. If you wanted to, for example, filter for individuals who were students, you have a bit of a problem because you have to filter for people who are either student or student informal worker, or student trader, or student other, and so on and so forth. It may be easier to simply check which of these values have the string or the substring student within them. And that's what we're going to learn how to do now. So let's open up a new code chunk and type yao.query. And in our query, we access the occupation column. And then we're going to use the str.contains method on that. And we check which occupation values contain the string student. So now if we run this, let's look at the output, specifically the student one. You can see we have students, but you also have student informal worker and so on, but the others are abbreviated so you can't see them here. Let's put a comment here and say values containing the string student. And let's open a new code section and see how we can negate this. So similar to the other query methods, we can simply negate this using that tilde function. So I can wrap all of this in a pair of parentheses and then put a tilde outside of that. And if we run this, we get the complement of this other one, which is all the individuals that don't have student in that occupation column. So we say values here not containing the string or substring student. Now you can use the OR operator, that vertical bar, in a special way within str.contains. So let's see how. If I copy this, and let's say we wanted to select for people who are either students or farmers. First of all, let's delete this comment because that's no longer relevant. And let's remove the negation. So remove this negation. And now we're going to add a vertical bar and check for people who are either students or farmers. And notice that we don't put any space here, because if you put a space, it's going to check for the string space farmer. That's not what we want. We want the string farmer. So now if we query this, you can see we have some students. We also have trader farmer here, and any other value that has farmer is going to be included. And let's put a comment here that says contains student, or farmer. Now here is a practice question for you. I'll call it symptoms. And what you're going to do is query Yao to find respondents who reported either cough or fever as symptoms. Your answer should have 219 rows. Importantly, symptoms is one of those multi-answer columns, so they could have multiple symptoms, also separated by double hyphen here. So pause the video and try that out. So now let's go through our list of learning objectives and see if you feel like you're confident with these. So by now you have the basic idea of how to use the query method to keep or drop rows from your data frames. You know how to use relational operators like greater than, less than, equal to, and not equal to. In addition to the is/in method, you can combine these conditions with and or, so the ampersand and the vertical bar. You can also negate these conditions with the tilde. You can use the is_na and not_na methods to access those NaN values. And you can use the str_contains method to specify conditions as well within your queries. So congrats on getting through this lesson. It's a long video, but it's also an important concept, so it deserves some time. Hopefully you are feeling somewhat confident. I'm proud of you for getting this far. Keep going and keep practicing, and I'll see you in the next video. Bye-bye.
For more resources, visit our website, where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.